Hello, in this tutorial, we will discuss what is a slicing software and we will go over the basics of how to use a Makerbot print. You've already learned how 3D printers work in previous lessons. Let's just have a very quick review. 3D printer is just like a very controlled glue gun. It begins by laying down a two-dimensional layer of plastic on a flat surface. It then continues by laying additional layers of plastic on top of the previous ones. As it continues to stack these layers, it begins to form a three-dimensional object. But now you may wonder, how does a 3D printer know what to print on each layer? This requires the use of a software called slicing software to generate some instructions that the 3D printer would understand. So the main purpose of a slicing software is to take a 3D object file, slice it into the two-dimensional layers that was described earlier, and then translate that information in a language called G-code that can be understood by a 3D printer. The G-code serves as an instructional manual, which basically tells the printer how to move along the X, Y, and Z axis, how much filament to extrude, and etc. So that we don't have to worry about these issues. You can also think about this slicing software as the print settings for a normal two-dimensional printer in a Word document. For example, you can specify what directions to print, in what color, and the layout of the content. Similarly, we use the slicing software to configure different print settings for a 3D printer, such as the position and the orientation of the objects we want to print. We can also control more detailed settings, such as the thickness of each layer, and we will take a more in-depth dive on these detail settings in the next video. So there are a variety of slicing software available for different printers, and Makerbot Print is just one of the slicing software made for Makerbots. So the first thing you need to do is to download the latest Makerbot Print on the Makerbot website. So you can just type in Makerbot Print download. And the first link is that. And then you just need to choose the file based on what computer systems you have. And then click on download. After you download it and install it on your computer, we can close the browser and we can open up the Makerbot Print. So once you install it, open it up and sign up for a free account and log in with that account. So you can click on here and I'm already signed in. And if you haven't done this, you should do that first. So first, let's take a look at the interface. So the four icons on the left panel are hyperlinks to direct you to different Makerbot services. For example, this will direct you to the Makerbot.com main website. And this allows you to go over to the Thingiverse.com. So Thingiverse is a 3D design sharing platform that you can find a lot of free 3D models to download or remix. If you don't have any models you made yourself, you can find and download a model from Thingiverse to print. Now let's take a look at how we can use Makerbot Print for printing purposes. So the first thing we want to do is set up our software to slice for a specific 3D printer. This will establish parameters for the software based on the physical constraints of our printer, such as how big is our build plate and how much volume is available for us to print. This is also very similar to a print setting in the Word document. You first need to connect and choose a printer to print from. So we click here on the lower right, you click on the printer, and I already have this printer Replicator Plus added. And if you haven't done that, you should click on Add a Printer and select Add an Unconnected Printer. Basically, for Makerbot, you can use a network setup so that you can send out the file directly, but in most cases, you want to use this because the 3D printers are not connected to your computer. So you want to find the correct printer, and the one for our studio is called Makerbot Replicator Plus. So it's over here. So you click on it and I already have it added. Great. The next step is to add our 3D models. We can do so by accessing the project panel in the top left and select Add Models. You can either go over your documents and find the correct model, or for example, my model is already located on my desktop, so I can just drag it to this box to add models. Okay, so now I've already added the model, and you can see the model is also displayed on the build plates. In this specific software, there are a handful of 3D object types that are supported, including STLs and even SolidWorks and Inventor files. We can add multiple different files in this process as well, and we can add duplicates of the same file if needed. For example, I can right-click here and duplicate. And I can say how many I want to duplicate, and I can say maybe 2. And now you see that I have 3 same keychain files on the build plate. So this is a keychain that I designed myself. So I will use that as a demo to show you how to use the Makerbot print. You can also set up a different build plates, but this feature is not often used. You just need to make sure all your files is on the same build plate if you want to add multiple files and wish them to be printed at the same time. So now let's take a look at the top right panel, since we've already have the 3D models added. We see 2 icons that are separate. These represent the 2 views in the software. The first one is called the model view, which is what we want to be active when we are moving around our objects and choosing different print settings. So this is active now. And when we're moving things around, we can see it. And the next one is called estimates and print view. This is what we use to see how long our print will take and how much material it will use, and also see the individual layers that will be printed. This we usually use after we have settings configured, and we can take a look at the print time and the simulation. We'll demo this later once we go over all the correct settings. So going down the right side menu, the first option we have is model info. We use this to select the units that our model was designed in. This allows the software to have a sense of a scale of our object. For example, this was designed in millimeter. For example, if I choose a different units, then the object is enlarged. So I will change it back. The next option is print settings. We will take a closer look at this setting in the next video, as this is where we will spend most of our time in the slicing software. And the next up is arrange. This allows us to move our objects around the build plates. You typically want your objects to be relatively close to each other so that the print head doesn't spend too much time hopping between objects while printing. You can also click Arrange Build Plate, and the software will automatically position the object for you. So let me click on Arrange Build Plate. You see that the software automatically positions the object for me. But sometimes this isn't the most optimal positioning, so you can still click and drag your model around to adjust the positioning manually as you like. So I will go back and click Arrange Build Plate. Maybe it's not very easy to see all the details of the objects, and they may have overlappings. So to zoom in and zoom out, you can scroll down the middle button of your mouse to zoom in and zoom out. You can also use the right click and hold on to it and rotate your mouse. And this will rotate the build plate, so give you a different perspective of your build plate. So for example, this way I can see how they are aligned and how close they are to each other. So the next option is orient. This allows us to rotate our object around the X, Y, or Z axis. We can type in specific angles, for example, 180, and click on Enter, and to rotate our models. So there are some general guidelines for rotating your objects. Basically, you want the largest flat surface on the build plate. For this case, I want the back of my keychain because it's a flat surface. I want it to be laid down on the build plate. And if there are no flat surfaces available, you want to pick the largest surface area to be placed on the build plate. And finally, you want to position the objects near the center, so the extruder doesn't need to travel too far to print, so that will definitely save print time. So the last option here is scale. This allows us to stretch or compress our object in the X, Y, or Z directions. If we select uniform scaling, this will allow our object to scale the same amount in all directions. For example, here I can type in 200. This will make the object twice in terms of size. But you can also turn off the uniform scaling. And for example, if you only want to scale along the X axis, and I can do that by just turn off the uniform scaling and type in a specific amount in X. So I will undo that. This now concludes our tutorial for how to get around Makerbot Print. In the next video, we will discuss the print settings menu and show you how to export our sliced 3D model.